So hello everyone and welcome back to a brand new video, and in this video I'll be covering problems from Geeks for Geeks Jobathon 13. And sorry, I have not been active for a while because I had my college exams, so I was busy in that, but you can expect regular videos going forward. Yeah, so let's start with the problems. So the first problem is odd series. So the problem is quite simple. So you have been given some integer n, and you just have to find the nth term of the Fibonacci series, right? So you just have to find the nth term of Fibonacci series. But there's a slight twist. For example, you know that f of 0 is equal to 0, f of 1 is equal to 1 in Fibonacci, and similarly f of I is equal to f of I minus 1, f of I minus 1 plus f of I minus 2, right? So this is the Fibonacci series. But in the problem, we have a slight twist. That is, there is one extra condition. That is, for when I is divisible by 5, that is when I modulo 5 is equal to 0, f of I is equal to 11. So, right? So, we have this extra condition. So, given the Fibonacci series and this extra condition, you have to find the nth term, that is f of n of this series. So how can we do this? So we can do this in the same way we solve for Fibonacci. So we can use recursion, right? And to avoid TLE, we can use memorization, right? So we will use recursion plus memorization to avoid TLE. So as we have recursion, we will define a recursive function. Let's say find nth, and that will give us the answer for the nth term. That is, it will give us f of n. And as we are using recursion, we have to define some base cases. So we will define the base cases. When your n is equal to 0, your answer is obviously 0. So we can just return 0. If your n is equal to 1, we can just return 1. And if my n modulo 5 is equal to 0, I can just return 11, right? So these are my base cases. And as we are using memorization, so we also have to take care of that. So we will have a memorization step. That is, if we already know, or if we memorize solution, for n, then just return solution of n, right? Otherwise, else we don't know solution of n and we have to find solution of n. So solution of n is how much? That is solution of n, that is basically f of n is equal to find nth n minus 1 plus find nth n minus 2, right? And in the problem, you also have been told to find the answer modulo 10 to the power 9 plus 7. So we can add an extra parenthesis here and do modulo 10 to the power 9 plus 7. So if we know the answer, we can just return solution of n. Otherwise, we have to find solution of n. So that is find nth n minus 1 plus find nth n minus 2 modulo 10 to the power 9 plus 7. And in the end, we can just return solution of, right? So that will be the entire recursive solution. You can also write a iterative solution that works as well. So if you guys want to see the code for this, here is the code. So here are my base cases. That is, if n is less than 2, return n. If n modulo 5 is equal to 0, return 11. So these are the base cases. And then here is the memorization step. That is, if solution of n is not equal to minus 1, that is, if we already know the solution for solution of n, we can just return that. Otherwise, we have to compute the solution for n. So we'll do solution of n is equal to find nth n minus 1, find nth n minus 2 modulo, and in the end we can just return solution of n, right? So that was the first problem. I hope that was clear enough, and I think it was quite standard. So let's move on to the second problem now. That is the water problem. So in this problem, we have been given n water tanks. Let's call them A. So we have tanks with capacity A1, capacity A2, A3, A4, so on up to AN. And we have a bucket of size B, right? So every minute we can choose some element AI where AI is less than or equal to B and remove AI, right? For example, let's say my A2 is less than or equal to B in this case, then we can just take A2 and remove A2, right? And after we remove some element, all the other tanks will leak, and their value will be less by 1. For example, after we remove A2, all the tanks will leak, so the new values will be A1 minus 1, A3 minus 1, A4 minus 1, so on up to AN minus 1, right? So after every step, every tank will leak 1 unit of water. So now we again have to do the same step. So we again have bucket of size B. So we have to choose some element AI which is less than equal to B. So let's say my A4 minus 1 is less than equal to B now. So I will choose and remove A4 minus 1, right? So after this step again the tanks will leak. So my new value will be how much? My new value will be A1 minus 2, A3 minus 2, A5 minus 2, so on up to AN minus 2, right? I have removed A4 and I have removed A2. So in every minute you have to remove some tank, and in every minute you want to remove some tank, and you don't want to miss any chance, right? So you have to remove at least one tank in every minute until all tanks reach capacity 0, right? So you have to do this, and you have to find the minimum value of B. You want to find the minimum value of B that is required to do so. So you want to find the minimum value of B required to do so, right? So how can we solve this? So the very first observation that we need is, let's move on to the observations. So the very first observation is that we will sort the array and remove lowest elements first, For example, let's say I have my array A1, A2, A3, so on up to AN. Let's say I sort the array and I get a new array A dash. So I will have A dash 1 is less than A2 dash is less than A3 dash, so on up to less than equal to AN dash, right? So after I remove the first element, my value of last element will be reduced by 1. So I will have my new value as AN dash minus 1, right? So when you will remove the first elements, the larger elements will keep on becoming lower, right? So it will be easier to remove AN dash minus 1 at the end, right? So if you keep removing these elements, in the end you will have some value AN dash minus, let's say 7, right? So first of all you had AN dash, and as AN dash is the highest element, it will be hard to remove AN dash, right? But if you keep removing the lower elements first, at the end your value of AN dash will be lower, and it will be easier to remove AN dash, right? So that is the first observation. So if you have some bucket B, it is always optimal to sort the array and remove the lowest elements first. So that is the first observation. So let's move on to the second observation. That is, you have to find the minimum value of B, right? And I have always told you that whenever you have been asked to find minimum or maximum, the thing that should think about is binary search. So how can we apply binary search on this? So if you think about this, I can divide this into two parts, right? Here is my answer, right? This is the minimum value of B, right? If you are able to achieve the answer with B, you will also be able to achieve the answer with B plus 1, B plus 2, right? Because if you are able to remove all the tanks using a bucket of size B, you will also be able to remove all the tanks with bucket of size B plus 1, right? So you can say answer for all the values greater than equal to B is equal to yes, and answer for all the buckets less than B is equal to no, right? So you can easily see there is a boundary here, and we can binary search for this boundary, right? So you can define your lower size equal to 1, that is your lowest bucket size, and your highest bucket size equal to 10 to the power 9. Then you can run a binary search. Your mid will be how much? Your mid will be low plus high by 2, and you can then just sort the array and try to remove all tanks. If you are able to remove all tanks, your answer is yes, right? Then that means that you are on the right side, right? So you want to move on to the left side. So you can do your high is equal to mid minus 1 and your answer is equal to mid. Otherwise your answer is equal to no, then you have to shift your left point. So you have to do low is equal to mid plus 1, right? So that will be your binary search. So define your low equal to 1, high equal to 10 to the power 9, do a binary search, sort the array and try to remove all the tanks. If you are able to remove all the tanks, then your answer will lie on the left side, right? So you will do your high is equal to mid minus 1 and your answer is equal to mid. Otherwise your answer will lie on the right side, so you will do low is equal to mid plus 1. So that is the solution. And if we see here, I have my int low equal to 1, high equal to 10 to the power 9, answer is equal to 10 to the power 9. I take my array and I sort it. Then I do a binary search. I define my mid is equal to low plus high by 2, OK is equal to 1. That is if I am able to remove all the tanks or not, right? Then I will iterate over all the elements. I will try to remove the tank. If I am not able to remove the tank, that is if my value of tank is more than mid, right? That is if capacity of my tank is more than mid, then I will not be able to remove that tank. So my OK is equal to 0. That is I cannot remove all the tanks and I can just break out. Otherwise I have removed a tank, so I will increment my counter variable, my counter, right? Because every time you remove a tank, all the other tanks are leaking, right? So you also have to keep track of their leaking. So every time you remove a tank, the leak value will increase. So my current value is representing the leak value, right? So this is my leak value. And in the end, if OK, that is I am able to remove all the tanks, answer is equal to mid, high is equal to mid minus 1. Otherwise the answer is not possible and it is lying on the right side. So I will do low is equal to mid plus 1 and I can just return the answer. So that was for the second problem, and let's move on to the third problem. That is sum up the beauty. This is also a very standard problem, right? So in the problem we have been given some array, let's say 2 4 2, and your beauty of subarray is equal to number of unique elements in that subarray. For example, if we take 2 4 and 2, you can see that only 4 is unique here as 2 is repeating, right? So my beauty of this subarray, so I can say my beauty of 2 4 2 is equal to 1 only, right? So you can say your beauty of subarray is equal to number of unique elements in the subarray, or you can say that your unique elements will contribute 1 to the subarray, right? It is also a valid explanation. So that is the definition of beauty. So given this definition, you have been given some array A of size n, right? You have been given some array A of size n, A1, A2, A3, so on up to An, and you have to find the sum of beauty of all subarrays. So that is the problem, and value of n is up to 10 to the power 5, right? So it is not possible to iterate over all these subarrays. So how can you find the beauty of all subarrays? This is a very well-known problem, right? Because if you have to find score of some subarrays, it is obvious you will not be able to iterate over all the subarrays. So you can rephrase the problem. So instead of saying find score of all subarrays, you can rephrase the problem as how much does a element contribute to subarrays? How much does the element contribute to subarrays? So if you want to see an example of this, for example, we have some element, let's say 2 4 3 7 2 8 9 10 and 2, right? if you have to find the contribution of this element, how much contribution will this element give to your subarrays, right? So as you can see here, one unique element will contribute one to the subarray, right? So in how many subarrays will this element be unique? So contribution of this element is equal to number of subarrays. It will be unique in number of subarrays. It is unique in. So how can we count that? So if you see how many subarrays will this element be unique in? So as you can see, we have a 2 here and we have a 2 here. So if we include any of these 2's, this element 2 will not be unique anymore, right? So the subarray, so the subarray must lie between these boundaries, right? So the subarray must lie between these boundaries. And let's say if we have x elements on this side, right? If we have x elements on this side and we have y elements on this side, then the number of subarrays including 2 will be how much? It will be x into y, or you can say xy, right? So this element 2 will occur in x into y subarrays, and it will be unique element in x into y subarrays. So it will contribute x into y to the answer, or it will contribute x into y to x into y subarrays, and it will contribute x into y to the answer, right? So you can say it will contribute answer plus equal to x into y. That is number of subarrays. This is unique number of subarrays. This is unique. So you can do this for every element, right? So for every element, count its contribution, and that will be your answer. So if you guys want to see the code for this, the code is also pretty simple. So I have a map, right? So I will use a map to store the occurrences. So because I want to store the occurrences of 2, right? Because I want to know when is my 2 occurring on the left side and when is my 2 occurring on the right side. So I will keep a map that will store the occurrences. Let's say it is at index I, it is at index j, and it is at index k. Then my answer is how much? It is j minus I into k minus I. So sorry, k minus j, right? It is the number of subarrays. So I will use a map to a vector to store these occurrences or indexes. So I will go over the array and push -1. Then I will go over the array and push the index of the elements where they are occurring, and then I will push n at the end. Why I'm doing so? Because let's say you have your array something like 3, 4, 7, so on, right, up to 7, then 9, 10, right? Then there is a boundary here, right? This is index -1 and this is index n, right? So hey, there is also a boundary here, right? So that's why I am pushing in -1 and n to all the elements, right, to define these boundaries. All the elements must lie from 0 to n minus 1, right? So I am pushing -1 and n as boundaries for every element. So then I will iterate over my map, and for every element I will iterate over its indexes, and my answer will be how much? It will be v of I minus v of I minus 1 into v of I plus 1 minus vi. That is, if I have 2, so on 2 here, 2 here, let's say this is index I, this is index j, this is index k, then how much will these 2 contribute? It will contribute k minus j into j minus I, right? So I am adding this for every element, right? That is what you are seeing here. V of I minus v of I minus 1 into v of I plus 1 minus v of I, right? And in the end I can just return the answer. So that is the entire solution, and if you guys have some doubts, feel free to ask in the comments, and I will be more than happy to answer your doubts, and I will see you guys in the next one. Bye bye. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि या मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.